abstractive summarization. Now, what do we mean by query-based abstractive summarization? It means it to generate the summary of a document in the context of a query. So, what does the abstractive mean? There are two ways to generate the summary of a document. First is extractive and second is abstractive. Extractive methods work by selecting a subset of existing words, phrases, or sentences in the original text to form the summary. There is no such natural language generation involved in it. Rather, abstractive methods builds an internal semantic representation and then use natural language generation techniques to create a summary that is closer to what a human might express. Such a summary might include verbal innovations as well. In general, abstractive summarization aims to cover all the salient points of a document in a compact and coherent fashion. Query focused summarization highlights those points that are relevant in the context of the query. Each summary is abstractive and not extractive in the sense that summary does not necessarily comprise of a sentence which is simply copied from the original document. Now coming to the application part, the following screenshot shows the extractive summary generated by the Google for a given query. Since it is extractive, the summary does not directly answer the query asked by the user, instead provides the best match sentence from the top ranked page. If the proposed model is to be used, a personalized abstractive summary could have been generated. Now coming to the data part, the data set is from the Debatepedia, an encyclopedia of pro and con arguments and quotes on the critical debate topics. There are in total 663 debates in the corpus. These debates belong to the 53 overlapping categories such as politics, law, crime, environment, health, morality, religion, etc. The training data is given in the form of a triplet, that is document snippet, query and ground truth summary, and model is trained. Now coming to the model part, we have majorly three parts: encoder, decoder and the attention based encoder decoder. So as it is a generative model, we need to generate the probability of next word to be generated, which is based on the previous word. The project uses an attention based encoder decoder model along with a similarity reduction to alleviate the problem of repeating phrases in the summary. Now what do we mean by attention based encoder decoder? It encodes the query and the document first using RNNs with GRU by learning the hidden representation of query and document words. Then the attention is first applied to the query for a document for a particular time step and then applied to the document to predict the word for the next time step in the decoder. So what do we mean by this is, first the word is created at the initial time step, that is W0. This W0 is fed to the query attention model. The query is attended here and then this attended query is then fed to the document attention model component. The document is attended here and it is fed to the diversity cell. This diversity cell has some functioning here. I'll explain it later. And the next word is generated for the next time step. So this is the whole cycle for generating each word in the decoder part. So now what this diversity cell does is, it does the task of similarity reduction. This is used to address the problem of repeating phrases. The root cause of repeating phrases which is addressed is, if the decoder produces the same phrase or word multiple times, then it is possible that context vectors being fed to the decoder at a consecutive time steps are similar. Therefore, before giving input to LSTM, the vector components of the current time step, which is similar to the previous time step vector inputs, are removed. That is, they are made orthogonal to each other so as to generate the different words. So this way we have removed the similarity between the words. Now these are the scores which are generated by the model, that is difference between the ground truth and the predicted summary. These are the screenshots of training data that we have done, the summary generated at the time of training and the loss. These are the challenges and limitations. So the challenge was to get comfortable with deep learning techniques, understanding the intuition behind the working of different models. Models here meaning the models we used for different things like orthogonality and similarity reduction, and other models such as GRUs, LSTMs, etc. Now generating large datasets including the ground truth of the queries was the challenge here, and one limitation what we were having was that it is limited to single document summarization. It did not include multiple document summarization. So this was all from my side, query based abstractive summarization. Thank you and have a nice day.